Good morning or good afternoon, good evening, whenever you're watching this. All right, we're starting a new unit today. It's all going to be about polynomials. So a polynomial, you may recognize this prefix poly, which means many. All right, a polynomial is when I take a monomial, which is just a one-term item like 3 or negative 2x or y squared or something like that. So I take a monomial, or I take the sum or difference of monomials, each monomial then being called a term. All right, so very math definition there. It's a monomial or the sum or difference of monomials. A polynomial means many terms. So it's a math expression that has multiple terms involved. Might be nice just to go down here and look at these examples. Each of these in this column here are an example of a polynomial, because it could just be something like 6 or x or 4y, or we could be adding or subtracting those monomials. X plus 3, 2x to the third minus 5x squared minus 2x. So it's these terms being separated by addition or subtraction. All right, now, what makes a polynomial a polynomial? What are some key things here? Well, there can be no negative or fractional exponents. There can be no square roots of variables. And there can be no variables in the denominator. Okay, so your variables all better be nice. No negative or fractional exponents. You can't have like the square root of x. You can't have any variables in the denominator. All right? Now, a couple other definitions. The degree of a polynomial. So the degree is the greatest exponent of any term in the polynomial. Okay? So, to find the degree of a monomial, you find the sum of the exponents of all its variables. So if you're doing something like x squared y to the fifth, the degree would be 7, because it's 2 plus 5. All right? Constant terms, so if you're just dealing with a number like 2, that has a degree of 0. All right? The standard form of a polynomial is written in order from greatest to least degree. And the leading coefficient is that once it's in standard form, it's going to be the coefficient, which remember is just the plain old number, of the first term. Okay? So this chart really kind of helps set this up. All right? We could have a degree of 0, which is just a number. A degree of 1, because x to the first plus 3. A degree of 2, 3x squared. A degree of 3, because our first thing is 2x to the third. All right, so if you notice in all of these examples, they're written in standard form because they're in decreasing order in terms of your degrees. Like this quintic function has an exponent of 5, then 2, then 1, then your constant. Okay? Now, a couple key phrases to know here is that a constant is just a plain old number. Linear is when you have degree of 1. A quadratic is when you have degree of 2. And a cubic is when you have a degree of 3. All right, quartic and quintic functions you'll get into in future classes. All right, but also those are vocab words dealing with the type of degree polynomial we're dealing with. We also have vocab that deals with the number of terms. So if there's just one term, it's a monomial. If it's a 2-term, it's binomial. If it's a 3-term, it's trinomial. So these tell me that this is a 1-term, a 2-term, and a 3-term polynomial, depending on what I'm dealing with. Okay, so those each have their own special vocab words. Anything that's 4 terms or more, we just call a polynomial. We don't have a special name like a monomial, a binomial, or a trinomial. Okay? And to remember that, think bicycle has 2 wheels. So bi is a prefix that means 2. Tri is a tricycle that's got 3 wheels. So a trinomial has 3 terms. Okay? So let's get to our first example. Determine whether the expression is a polynomial. If it is, write it in standard form, find the degree, the leading coefficient, and classify it using these vocab words. All right, so is this a polynomial in A? Yes, it is. Because we have no negative or fractional exponents, no square roots, no variables in the denominator. So if I wanted to write this in standard form, I just need to write it from highest degree to lowest degree. So negative 4a cubed plus 2a minus 1. The degree is the exponent on the highest term. So that's going to be 3. The leading coefficient is the number on that first term, which is negative 4. And the classification is that this is a cubic, because that's what it is based off its degree. It has an exponent of 3, so it's cubic. And there are 3 terms, so this is a cubic trinomial. All right, make sure you study this chart and understand those words. Next up, we have 10x to the negative 4th minus 8x to the a. So, a couple bad things. This is not a polynomial, so we don't need to fill out this stuff because we have a negative exponent and a variable in the exponent. All right, so that might be important to add up here. No negative or fractional exponents or variables as an exponent. Our exponents have to be nice. So that's not a polynomial. Next, we got 6x minus 4. This is a polynomial. It's already in standard form. The degree is 1 because the exponent on the x is 1. The leading coefficient is 6. And the classification is that this is a linear binomial. It's linear because the degree is 1. And it's a binomial because there are 2 terms. And then we get to 3/2 y. Yes, this is a polynomial. You may be saying, but there's a fraction. That fraction is the number, is the coefficient on that y. All right? The y cannot be in the denominator. So this is a polynomial. It's already in standard form. The degree is 1. Okay, because the exponent on the y is 1. The leading coefficient is 3/2, which makes this a linear, because the degree is 1, monomial, because this is only 1 term. All right, so that's an introduction to polynomials and everything that is involved with them. All right, make sure you pay attention to the next video where we're talking about how to add and subtract these polynomials together.